Okay, today we're going to be learning about inverses. The inverse of a function is written as f inverse of x. This little exponent of -1 means inverse. This symbol is the inverse symbol. To find the inverse of a function, first, anytime you see f of x, just write a y, okay? So let's go ahead and do that. Whenever you see f of x, just think of it as a y. Okay, now, whenever we solve for an inverse, you're always going to interchange x with y. If you don't like that word, just think of it as switching x and y. So what I'm going to do is, instead of a y, put x. Instead of x, put y. We just switched x and y, just the location. Swap x and y. That's step 2. Step 3 is to solve for y. So that means we're going to get y by itself. So notice, this is being divided by a 3. What is the opposite of dividing by 3? Yes, so we're going to multiply this side by 3, and that cancels out because those are opposites. We're also going to multiply this side by 3. What we are left with is 3x equals y minus 8. What is my next step in solving for y? Yes, thank you. We're going to add 8. So I have 3x plus 8 equals y. Okay, we successfully solved for y. Your last step is very simple. We're going to use our new notation that we just learned. This is how you write the inverse. F inverse of x is 3x plus 8. That is how you write the inverse. Those are some good comments. Let me do a note right here. In fact, write this down. This is the original. The inverse is written with a negative. If this is the original y, the inverse is written as y with a -1. Okay? So you can write it like this, or you can write the inverse like this. They're both the same. The little -1 exponent means inverse. So this could be your answer, or this could be your answer. They're both right. Okay? Let's do another example. So whenever you see f of x, just replace it with a y. It's easier to think about it that way. Now, whenever you're doing inverse, you always switch x and y. So this is x equals y squared minus 9. Okay, so what I'm going to do is add 9 to both sides. That's what you do first. I am left with x plus 9 equals y squared. Do you guys know how to get rid of a squared? Good. We're going to square root both sides. A square root cancels out with the squared. So we have the square root of x plus 9 equals y. And remember, we have to write the notation for inverse, okay? This is the notation for inverse. If you want to, you can also use f inverse of x equals square root of x plus 9. Okay, these mean the same thing.
And that's all you do, you don't think it like...
No, this is your answer. All right, next one. Same thing. This is a y. You always switch x and y. So this is x equals y plus 4 cubed minus 6. All right. Now we're going to add 6 to both sides. So we have x plus 6 equals y plus 4 cubed. How do you think we're going to get rid of a cubed? Yes, I heard someone say it. A cubed root. A cubed root on both sides. So this is a square root. To get rid of it, or let's say, if you square it, you can get rid of it. But if you have x squared and you square root it, that would cancel it out. If you have a cubed and you cubed root it, that would cancel it out. If you have x to the fourth power, fourth root would cancel it out. Okay? So here, the cubed root cancels out with the cubed. You're left with cubed root of x plus 6 equals y plus 4. We have one more step, guys. What should I do? Yes, subtract 4 from both sides. Notice this minus 4 is outside of the cubed root. This does not come together to become 2. Keep them separated. So your final answer is the cubed root of x plus 6. Then we subtracted 4. So this is your inverse. Now, we are going to prove that inverses are in fact inverses of each other. What I'm saying here is that this and this are inverses of each other. Let's prove it. So in order to prove that two functions are inverses of each other, if you take the composition of both and you get x, that means they are inverses of each other. So let's try an example. Let's prove to see if these are inverses of each other. So first, let's do f of g. We're going to put g inside of the f. So I'm going to write f nice and big. And I'm going to put g inside of it. Now, if this simplifies to x, that means they might be inverses of each other. Let's see. Won't this squared and this square root cancel? So I'm left with x minus 8 and then a plus 8. Negative 8 and positive 8 cancel out. I'm just left with x. Okay, that looks good. But to verify if these are inverses, I also need to do it the other way. So let's try it the other way. This time I'm going to write g big. Instead of an x there, I'm going to put in f. So let's put f inside of here. So that's x squared plus 8. Guys, what's 8 minus 8? 0, so that's gone. And doesn't a square root cancel out with the squared? I'm left with x. Since I got x when I did both compositions, that means f and g are inverses of each other. They're inverses. Let's try another one. Actually, you try this one. So you guys put g inside of f. Did y'all set it up like this? Okay, nice. And let's just distribute. Negative 4 times x is negative 4x, and it's over 4. Does this part make sense so far? Okay, a lot of people got confused last class. You can think of this as over 1. 1 times 4 is just 4. Okay? Negative 4 times negative 5 is a 20 plus 5. Okay, negative 4 divided by 4 is just negative 1. This is a negative 1x plus 25. I was not left with just x. So I can already tell these are not inverses. In the previous example, I got x at the end. Here, I got negative x plus 25. These are not inverses. Now let's talk about inverses when we graph. So guys, go ahead and graph this triangle. So it should look like this, -1, 6, 1, 2, 3, 4, 5, right here. -7, 2 is here, and -5, 3. Okay, connect your points and make a triangle. How do you find the inverse? Good. Flip it. So switch X and Y. So this is going to be your X value and this will be your Y value. We just switched it. And then plot those points and form the inverse triangle. I didn't change the numbers, I just switched the location. So now I have, and I'll do it in I'll do 6, -1. 2, -7. -3, 5. -3, -5. So this is your new triangle. What do you guys notice about the graph? Yes, it's a reflection. Do you guys know where it's reflecting across? Exactly. It's reflecting across this line, y equals x. This diagonal line is the mirror that it's reflecting across. So guys, just let me highlight it for you so you can see. This point mirrors this point. It's the same distance from that line. This point mirrors this point, and this point mirrors that point. Okay, so inverses are mirror images of each other. Okay, so write that down over here. They reflect across the line y equals x. So guys, what I want you to do is try to find the inverse of this line. Go ahead and graph this line and then graph the inverse. If you do it correctly, it should reflect across this diagonal line. So guys, go ahead on your paper, graph this line. This is the original line, and then graph the inverse. Okay, look up, make sure you graph the original line correctly. Now, guys, you should be graphing the inverse. All right, so I heard some great ideas. Someone said that this point right here is the point 110, and she just switched the coordinates. So on the inverse, the point 10, 1 will be on the line. That's right here. This point is 0, 8, so the inverse will be at 8, 0. This point is at -1, 6, so the inverse will have 6, -1 right here. Do you guys see what she did? She's creating the inverse line. She can continue this pattern. I can already tell what the slope is. It'll look something like that. Okay, another way. Okay, another way you can do this is algebraically. So guys, you switch x and y. And first you subtract 8, right? So you get x minus 8 equals 2y. What do you do now? Yep, you divide by 2. Divide by 2. Divide by 2. So that means the inverse is x over 2 minus 8 divided by 2 is 4. So this is your inverse graph. All right, so that means your y-intercept is at -4. 1, 2, 3, 4, right here. And your slope is 1/2. So up 1/2, up 1/2. And we get those exact same points that we were earlier. Okay, but it's going to be a mirror image.